Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about mechanics of deformable bodies. At ang ating magiging topic for today is all about unsymmetrical beam. Maaring tinatanong ninyo kung bakit ba kinakailangan nating mag-design ng beam na nasa uri na tinatawag nating unsymmetrical, ano? At papaano kung ang section natin ay unsymmetrical? How are we going to solve this kind of problem? Kaya sa discussion na ito ay makikita natin kung bakit kinakailangan gumamit tayo ng unsymmetrical beam at kung paano tayo mag-solve ng problem kapag ang sections natin ay unsymmetrical. Kaya puntahan muna natin guys yung ilang introductory concept about unsymmetrical beam. So alam natin guys mula dun sa flexure formula that the flexure stress varies linearly with the distance from the neutral axis. Hence, those beams such as wide flange sections, I-beams, or rectangular sections, which are actually asymmetrical beam, they will be subjected to the same magnitude of the tensile and compressive stress. It is because the fiber that are subjected to tension have the same distance as those fibers that are subjected to compression. Hence, they will be developing the same magnitude of the compressive and tensile stress. Yung ganaring klase ng design, the use of symmetrical beam is really desirable if material is both equally strong in tension and in compression. So sabi nga, yung design ng symmetrical beam is really desirable if our materials are considered to be equally strong in tension and in compression, if they have the same capacity to resist tension as well as the capacity to resist compression, then the use of symmetrical beam is really desirable. However, there are materials whose strength are not the same. Sometimes materials are stronger in compression than in tension. May mga materials kasi na talagang magkaiba yung kailang capacity to resist the tension and in compression. There are materials that are really stronger in compression than in tension. Now, for beams having this kind of property, then it is good to consider designing such beam using unsymmetrical sections. Maganda raw na i-consider na mag-design tayo ng ganyang beam na kung saan ang section natin ay unsymmetrical. Ang ideal treatment is to let both the stresses reach their maximum limit simultaneously. Para nagiging economical siya. Kasi if we shall be able to maximize their capacity, then our section becomes economical. And we can maximize them if we will be allowing that their limits shall be reached at the same time. Kaya kinakailangan magkaroon tayo ng unsymmetrical section. Now, how are we going to do it? So this can be done by designing the section such that the neutral axis shall be in a position so that the distance of the farthest fiber in tension and in compression is in the same ratio as the maximum allowable tension and compression. So yun yung konsepto na magandang i-apply para daw matiyak natin that their stresses will be reached simultaneously. Then we shall place our neutral axis. We shall be designing such that the neutral axis, itong neutral axis dito po will be at a position so that the ratio of the distance of the fiber subjected to tension and compression shall be equal to the ratio of the allowable stresses in tension and in compression. So if we shall be able to make it that way, then we shall be able to let their maximum stresses reach at the same time. And hence our design, bagamat yung ating section is unsymmetrical, will be considered to be economical. So para maipakita yan, para maipakita yung ganyang klase ng konsepto, ay naghanda ako ng isang problem dito na kung saan ay may papakita natin kung paano i-treat ang ganda ring klase ng problem kapag ang problem ay nangangailangan na tinatawag nating unsymmetrical section. So let us have this problem. So the problem goes that a 10-meter simply supported beam having a cross-section as shown, it supports a uniformly distributed load W. Okay, weight of the beam is assumed to be part of the W. Okay, and concentrated load of 20 kilonewton at midspan. So, in this problem, okay, the beam has an allowable compressive stress of 150 megapascal and an allowable tensile stress of 50 megapascal. And from here, we shall be required to determine the following. First, okay, we are required to determine the recommended value of the dimension B so that stresses will be reached simultaneously. And the second question is, we are required to find for the magnitude of the maximum W that can be supported by the beam. The beam cross section is shown in this manner. Okay, we have here a section that is unsymmetrical. So we have flanges on both end of the web. However, the flanges are of different size. The upper flange has a dimension of 60 millimeter and a thickness of 20 millimeter, while the lower flange has a thickness of 20 millimeter and a width equal to be an unknown value. They are put in place by a web having a thickness of 20 millimeter and a height of 160 millimeter. And this beam will be supporting a uniformly distributed load W, okay, aside from a concentrated load of 20 kilonewton which shall be placed at the midspan, and they will be simply supported at their ends. Okay, and the span of the beam is 10 meters. So, in order for us to solve for the problem, so kailangan ipakita muna natin yung situation, So, puntahan muna natin yung situation para maipakita natin at ma-analyze natin ng mabuti itong ating problem. So, in the given problem, sabi dito, we have a 10-meter simply supported beam. So, let us imagine that we have here our beam that is simply supported and the span is 10 meters. Okay, so it is to support a uniformly distributed load, of W. So there is now a uniformly distributed load of W expressed in kilonewton per meter and a concentrated load of 20 kilonewton at midspan. So there is also a concentrated load here at 20 kilonewton at midspan of the beam. And so we shall be expecting that because this is simply supported, we shall be having here a reaction at the left and reaction at the right, and we call this as R sub 1 and R sub 2. Okay, the first thing that we shall be solving is to solve for the reaction at the support. And because the beam is symmetrically loaded, it carries a uniformly distributed load of W plus a 20 kilonewton load at midspan. So we will be expecting that R1 and R2 will have the same magnitude. They will be equal in magnitude, carrying half of the total loads of the beam. And so we shall have here R1 being equal to R2, and this will be equal to the weight, 1/2 of the weight due to the uniformly distributed load, that is equal to WL over 2, and the 1/2 of the concentrated load of 20. And if we are going to substitute the value of L and P, so we shall be able to get the value of the reaction expressed in terms of the unknown W. And so we shall have here R1 being equal to R2, and this will be equal to 10W over 2, representing the total weight, divided by 2, plus 20 over 2. And if this will be simplified, R1 will be equal to R2, and this will be equal to 5W plus 10, and this will be our reaction. Now, after we have computed for the reaction, ay pwede nating i-drawing yung kanyang shear and moment diagrams. So, halimbawa, i-drawing natin yung kanyang shear and moment diagrams. Let us try to draw the shear and moment diagram. Here is our shear diagram. So, we know that we will have our shear beginning at 0. So, let's start with 0 here. Okay, let us have our 0 here. Then, after which, it will increase by an amount equal to R sub 1, which is equal to 5W plus 10. Kaya meron tayo dito 5W plus 10, okay, and we expect that it will be connected by a vertical line. Then, at the midspan, it will be reduced by 1/2 of W. Therefore, itong 5W will be eliminated. And so what will remain is a value equal to 10. And this will be connected with a straight line. That is down the right. Then, afterwards, we shall have a weight of 20 kilonewton. Therefore, it will be deducted by 20. Therefore, it will become negative 10. And it will be connected by a line that is directed downward, representing the magnitude of this 20. Then at the left support, we shall be subtracting from negative 10 the magnitude of the weight from this point up to that point, and that is equal to 5W. And so we shall have here negative 5W minus 10, representing the magnitude of the shear, and this will be connected with a straight line that is directed down to the right. Then finally, it will when we add the reaction of the support, which is equal to 5W plus 10, then it will go back to 0, and that becomes our shear diagram. Ano ba? Now, after we have computed for the shear diagram, we are now ready to draw the moment diagram. Okay? We solved now for the maximum bending moment. So, kung marami ka kung nakapag-solve ka na marami mga problem about shear and moment diagram, you will discover that the maximum bending moment for a uniformly distributed load carrying a magnitude of W will be equal to WL square over 8. At kapag ang concentrated load naman ay nasa gitna, you will have a maximum bending moment of PL over 4. Kaya from the combined loading condition, the total maximum bending moment will be equal to WL square over 8 plus PL over 4. Or, if you may want, you can get the maximum bending moment by simply computing this area, representing the area of the shear between the left support and the midspan. And when you compute for this, you will be arriving at the magnitude of 12.5W plus 50. So the magnitude that you will be getting will be the same when you use this formula, or when you use the relationship between the load, the shear, and the moment diagram. And so our maximum bending moment will be expressed now in terms of W. Ito yung ating maximum bending moment that is expressed in terms of W equal to 12.5W plus 50. Pakita natin itong moment natin. The moment will be concave in the downward direction. Diba? And because of that, sabi dito, mapapansin natin that the moment, the beam will be subjected to positive bending moment of 12.5W plus 50. And because of that, we will expect that the beam will be concave in the upward direction. So itong beam na ito will now be concaving in the upward direction. Diba? Now, anong implikasyon kapag nag-concave siya in the upward direction? Kasi makikita natin yan that if it will concave in the upward direction, then masasabi natin that the upper portion of the beam will be subjected to compression. Itong bahagi. Kung ito yung ating neutral axis, itong bahagi ng beam above the neutral axis will be subjected to compression. While the lower portion of the beam, yung lower part ng beam below the neutral axis, will be subjected to tension. Diba? Kasi nga, the beam is subjected to a positive bending moment, the concavity is upward, the upper portion will be subjected to compression, and the lower portion of the beam is subjected to tension. Sa pagkatwid, if this will be the case that this will be subjected to compression, then this distance, mula dito hanggang dito, will be our y sub c, or the farthest distance, the distance of the farthest fiber in compression. While this distance will be called as y sub t, the distance of the farthest fiber in tension. And because of this, we wanted to ensure that both the stresses will reach at the same time when this will be supporting this load. Sa makatwid, we shall be locating this neutral axis such that the ratio of the y sub c to y sub t, or y sub t to y sub c, shall be in the same ratio as the ratio of their allowable stress. And so from here, masosolve natin yung ating y sub c at yung y sub t. Kaya ipakita natin dito, no? Ipakita natin dito. Okay? So, masolve natin dito yung y sub c and y sub t. Ibig sabihin, the distance of the farthest fiber in compression and the farthest fiber in tension. If we will be applying that concept that the ratio should be proportional to the ratio of the allowable stresses in tension and in compression, then the ratio of y sub c to y sub t must be equal to the ratio of the allowable stress in compression to the allowable stress in tension, which are 150 and 50 megapascal respectively. So in here, yung dalawang megapascal will cancel and these two will also cancel. That becomes equal to 3. Now, if we're going to look at the relation between y sub c and y sub t, you will notice that yung total depth of the beam will be 20 plus 160 plus 20, and that is equal to 200. Diba? Kaya makikita natin dito, yung y sub t plus y sub c is equal to 200. Or, from here, we can solve that y sub c is equal to 200 minus y sub t. And if this y sub c will be substituted here, diba? Diyan sa value na yan. Therefore, our equation becomes 200 minus y sub t over y sub t is equal to 3, being the difference, the ratio of 150 over 50. And so, if this will be simplified, we shall have here 200 minus y sub t will be equal to 3 of y sub t. And then simplifying, we can solve for y sub t equal to 200 or y sub t equal to 50. Then after we have computed for y sub t of 50 millimeter, then we can also solve for y sub c, because y sub c is equal to 200 minus y sub t. Hence, y sub c is equal to 150 millimeter. Kaya nakuha na natin ito na yung ating neutral axis must be placed so that the distance of the farthest fiber in compression is equal to 150 as computed here. And the distance of the farthest fiber in tension is equal to 50 as we have computed here. And so we shall be using this neutral axis. Magagamit natin itong neutral axis kasi ang hinahanap natin is B. And how are we going to solve for B? Okay. So we can now solve for B by knowing the concept that yung neutral axis daw coincide with the centroid of the section. Diba? Itong neutral axis kasi yan, nandyan yung ating centroid. And we understand that if we will be summing up the moments of area about the neutral axis, it will be equal to 0. Diba? So that, from our lesson in the determination of centroid, we say that a centroid can be taken by the use of the principle of moments, the moments of area, so that the moment of area about any axis being equal to the product of the total area multiplied by bar sub y, where bar sub y will be the location of the centroid from one reference axis, shall be equal to the summation of the product of the individual area multiplied by the location of the centroid of that area from the same reference axis. Kaya kung gagamit tayo ng reference axis at this part, itong part nito, okay? Sa makatuwid, we can solve for the value of B if we will be applying the principle of moment. So para ipakita natin yan, gumamit tayo ng tabulated form computation na kung saan we shall be identifying the different areas, subdividing this into the different area. Okay? Halimbawa sabihin natin, I consider this part as my first area. Itong part nito, kulay pula, as my first area. And the area of that will be 60 multiplied by 20. I have here 60 multiplied by 20, and that is equal to 1,200. This area would have the centroid mula dito, diba? Diyan centroid niya, diba? And the location of the centroid, if we shall be using this as our reference, will be equal to 100, 20 plus 60 plus 10, that is equal to 190. So yung centroid niyan will be equal to 190 here. And so if we will be multiplying this area by the product by the location of the centroid from the reference axis, which is 190, then we shall have here y. And so the product of this will be equal to 228,000. Diba? So if we will consider this part, second part, kunin naman natin the second part. Diba? The second area would have an area equal to 160 by 20. So we have here 160 by 20. And the magnitude is 3,200. This area would have the centroid somewhere here, whose distance from the reference axis will be equal to the sum of 60 or 80 plus 20, which is equal to 100. And this will be equal to 100 here. So that if, we will be multiplying, itong area nito plus dy, we shall have here the ay, which is equal to 320,000. Diba? And the third area will be this area whose dimension is b, the unknown value of the width of the lower flange. The area will be equal to 20 multiplied by b, and so this is equal to 20 multiplied by b. The location of the centroid is somewhere here at a distance equal to 10 from the reference axis. Dito 10 ito. And so we have here 10. And this will be multiplied. The product of area will be multiplied by a. So we have here ay. So we have here 200 multiplied by b. Now, if all of this area will be summed up, then we shall have here the total area. And the total area will be equal to the sum of this plus this one. And so I have here 4,400 plus 20b. Diba? Samantalang if this area will be multiplied, this part area will be multiplied. Diba? We shall have here the total summation of the product of area multiplied by y. And this will be equal to 548,000 plus 200b. While the total area would have the centroid equal to 50, taken as the neutral location of the neutral axis, which is equal to y sub c. Kaya if we will be applying, substituting all of this value in this equation, pakita natin ito dito. Tanggalin natin itong part na ito. Okay? So, pakita natin yan, that the total area multiplied by the centroidal distance from the reference axis shall be equal to the summation of the product of area multiplied by y. This total area is equal to this one. Diba? 4,400 plus 20b multiplied by a bar sub y, representing the location of the centroid from the reference axis, and because the centroid is located at the neutral axis, that becomes equal to 50. Diba? Shall be equal to the summation of a multiplied by y, which is equal to this quantity, 548,000 plus 200b. If this will be substituted here, so you have here 548,000 plus 200b. So we can now simplify here because we have here an equation involving b. So we can solve for b, that b is equal to 410. Kaya itong b nito will be equal to 410. So that is the first question. So we can recommend that b must be 410 so that when this will be used to support this loading, then both the allowable stresses will be reached simultaneously. Now, the next question is, kung ito na yung ating pinili na location, considering that b is equal to 410, the next question is, what would then be the magnitude of the largest W before, so that the material will not break, will not fail. Sabihin, it will just be subjected to the maximum allowable stress of 50 for tension and 150 megapascal in compression. And so we shall now be working now on the moments of inertia. Kasi in the formula for the stress, we need to determine the moments of inertia. We shall be solving here the moment of inertia of the section with respect to the neutral axis, knowing that the neutral axis is at y sub t distance from the base, from the bottom of the section. And we have just computed that b is equal to 410. So we shall now be solving for the moment of inertia of this entire section. And how are we going to do it? Now, gusto kong i-recall natin yung ating konsepto about moments of inertia, particularly kapag meron tayong rectangular section. Halimbawa, meron tayo ditong rectangular section, na kung saan ito yung kanyang centroid. Ang dimension ng rectangle is b, ang kanyang width at ang kanyang depth ay d. So, kung ito yung kanyang centroid, di ba? Meron siya ngayon ditong tinatawag na centroidal moments of inertia. At alam naman natin na yung kanyang value ay equal to b times d cube over 12. Yun yung kanyang centroidal moments of inertia, or the moments of inertia of the rectangular section about an axis passing through the centroid. Now, if we're going to transfer or use the transfer formula at kunin naman natin yung kanyang moment of inertia about this axis that is parallel, that is passing through the base, which is defined here as xx. So, meron tayo ngayon dito moments of inertia about this axis, an axis through the base, and that is equal to bd cubed over 3. So, itong value nito, ay pwedeng i-derive sa pamamagitan ng transfer formula using that the centroidal is equal to bd cubed over 12 plus the area multiplied by d square over d over 2 quantity square, and it will be arriving at this magnitude that the moments of inertia about the base of the rectangle will be equal to bd cubed over 3. Now, bakit ko ito pinakita? Kasi kung mapapansin natin, bagamat ang section natin ay in the form of unsymmetrical beam, that is parang inverted T siya, di ba? So we can now use this concept in defining or in determining the moments of inertia of this section. Ipakita ko dito yan, napakita natin dito yan. Okay, nilipat ko lang, So, pakita natin na yung ating section ay pwedeng buuin ng tinatawag nating composite section. So sabihin natin na itong section na ito ay binuo muna ng isang rectangle, di ba? Kinover ko muna yung rectangle, and we will notice that if we're going to apply this concept, we can get the moments of inertia of this rectangle about this neutral axis representing the base of that rectangle, di ba? And if we're going to apply the formula, this would have a value equal to the moments of inertia of equal to 60 representing the width multiplied by 150, di ba? 150 cube representing the height of the rectangle. That is actually the distance of the farthest fiber in compression. That is 150. Kaya lumalabas itong rectangle na ito ay may moment arm about this axis, which is the neutral axis of this beam cross section, equal to 60 times 150 cube over 3. Pero tandaan natin na hindi yan yung kabuuan, hindi yan yung talagang section. Kung makikita natin, ang section natin diyan ay yun lamang shaded blue. Now, kung itong rectangle natin ay babawasan natin itong dalawang kulay pula, di ba? Pagkatuwid, makukuha natin yung tamang moments of inertia ng maliit na tina yan, di ba? Itong tina ito, yan. So, but this red also coincide with the neutral axis, and these are also the base of the rectangle, these two red rectangles. And so if we shall be subtracting the moments of inertia of these two red rectangle, therefore we shall have here minus twice of 20 representing the width of this rectangle na kulay pula. And the height of the rectangle will be the difference between 150 minus 20, and that's equal to 130. Yeah, I will have here minus 2 times 20 multiplied by 130 cube over 3, representing the moments of inertia of the two red rectangle, which is supposed to be deducted from the larger rectangle that I have just shown a while ago. Now, but we will be considering the bottom part, the lower part of the neutral axis. Now, I will consider this rectangle. Mag-drawing ako ng rectangle dito. Yung rectangle naman ito, di ba? If we will be adding this rectangle, then this rectangle would also have a moment of inertia about this neutral axis of the section, which is coinciding the base of that rectangle. And using the same concept, this would have a moment of inertia equal to 410, diba? Multiplied by 50 cube divided by 3, representing now the total moments of inertia of this rectangle. But that rectangle is not actually the total area below the neutral axis. We have to consider that there are smaller rectangles here that should be removed. These two red smaller rectangles. So if these rectangles will be removed, then therefore we have to subtract the moments of inertia of those rectangles, which are actually coinciding also with the neutral axis of the section, whose dimension shall be equal to 400 10 minus the width, which is 390 divided by 2, and that's equal to 195. Diba? And the height will be equal to 50 multiplied by 20, and that is equal to 30. Kaya lumalabas, I will have 2 of 195 multiplied by 30 cubed divided by 3. So if this will be now simplified, then this gives us now the total moments of inertia of the beam cross-section with respect to the neutral axis. So, ganun natin kinocompute yung moments of inertia. Medyo mahaba-haba, pero mapapansin ninyo na effective siya, particularly kapag ang naging section natin is in this kind of section. Okay? So, if we will be simplifying this, moments of inertia, ang moments of inertia natin will become 5178000. The unit will be a millimeter to the fourth. Now, after we have computed the moments of inertia of the beam cross-section with respect to the neutral axis, diba? Now, we are now ready now to compute for the magnitude of the uniformly distributed load, W, that can be carried, aside from the concentrated load at the midspan of the beam. Okay, so let us recall, yung maximum moment kanina na-compute natin at 12.5 W plus 50. Take note that the unit of this is kilonewton meter. Take note, kilonewton meter. This one is in millimeter. So, kinakailangan maging alerto tayo on the conversion because we cannot simplify the equation if we will have different units. So, we'll have to convert one unit into another. Okay, yung allowable ay yung kanyang magnitude of y sub c. Itong y sub c natin, di ba? Ay 150. At alam naman natin yung kanyang allowable stress in compression is also 150 megapascal. Now, yung kanyang y sub t, which is the distance of the farthest fiber in tension, is computed to be at 50. And we know that the allowable stress in tension is also equal to 50 megapascal. Now, if we will be substituting this in our equation for the stress, that stress is equal to mc over I, na kung saan, yung stress will be the allowable, allowable stress, m is the maximum bending moment produced, c is the farthest distance, the distance of the farthest fiber in either tension or in compression, and I is the moments of inertia of the beam cross-section with respect to the neutral axis. Take note that this value is already computed here. Itong C na ito ay depende kung anong gagamitin nating allowable stress. So if we are going to compute for the allowable stress of 150 megapascal, but therefore this C will be equal to y sub C. And the moment will be the same as 12.5 W plus 50. So let us now try to substitute. We shall have here, the allowable stress of 150 unit is megapascal. The equivalent unit of megapascal is Newton per square millimeter. Okay, this 12.5 plus W plus 50 is actually this moment, which is in kilonewton meter. So I have to multiply it by 10 to the 6 because I need to convert that kilonewton meter into Newton millimeter. Para Newton millimeter ito, this will be millimeter, this will be millimeter to the fourth. You will notice that every unit will cancel. Ang matitirang unit will be the unit that's being carried by W, which is in kilonewton per meter. And so we shall be able to solve for that W, and W will be equal to 0.1424 kilonewton per meter. Okay? So I hope, guys, that you're able to follow the discussion that I have prepared for you about unsymmetrical beam. So you are able to understand why do we have to use unsymmetrical beam, and how do we compute for the moments of inertia of the beam when the beam is unsymmetrical, and use those moments of inertia and all other properties in dealing with sections that are unsymmetrical. Once again, guys, thank you for watching.